because we use X-rays to probe matter. We probe this matter by shooting these X-rays out of this tube at whatever our sample is. And so the X-rays come out at a certain known energy and they knock off electrons. So we all know that the structure of matter is atoms, and these atoms are formed with a nucleus and electrons orbiting around it. These electrons orbit around the nucleus, and they're bound to it at a certain energy level. So these electrons, or the X-rays, come in and they knock off our electrons. So the electrons go shooting off in all directions, but we have a lot of electrons come shooting up this tube. So the electrons get curved around here by an electric field. Based on how much they curve, we can tell how fast they're going. And how fast they're going tells us their energy. And so their energy tells us how strongly they were bonded to that center nucleus. This bond energy can tell us a lot of information, including what that nucleus is. So by knowing what your nucleus is, you can know what your material is. And you can use it to tell if you have carbon in here, or sulfur, or lithium. You can tell almost any material. And you can also tell how it's bonded to its neighbors. As carbon bonds to another carbon atom, it shifts the electrons in its orbital, and that gives us a slightly different energy level. So I use that information to probe solar cells. P3HT PCBM solar cells have been around for the last 11 years, but they've been slowly coming up in efficiency and knowledge in general. They started out at less than 1%, and the newest solar cells today, not P3HT PCBM, but other organics, are over 8%. So that's a huge leap, and that leap is brought about by machines like this one. So the unique thing about P3HT PCBM is it's an interface of two different polymers, one of which has sulfur atoms along with carbon and hydrogen, and the other which only has carbon and hydrogen. So using this beam, we can tell if we have sulfur or if we have carbon and hydrogen. So this peak right here is due to sulfur, telling me that I'm looking right now at a P3HT polymer. I'm Roy Murray. I work for Professor Ismat Shah, and I'm at the University of Delaware.